Alright, very good evening to everyone. So my name is Mr. Boey and I will take you through the second half of the webinar. So broadly speaking, I'm going to touch on three topics. Well, firstly, the risk of electric vehicles. Secondly, what to do in an emergency with an electric vehicle. And thirdly, I'll briefly touch upon an introduction to EV chargers. Now, what are the risks in vehicles with high voltages? First of all, we need to know what are the vehicles that has high voltages. Now, we all know that battery electric vehicles has a high voltage traction battery. However, hybrid battery vehicles will also have batteries with high voltages. The difference between these batteries and the battery in a normal internal combustion engine vehicle is its voltage, and more importantly, its energy density and capacity. In a normal combustion engine vehicle, we have a lead acid cell battery which is at 12 volts. For hybrids, we have batteries with voltage levels of between 100 to 200 volts, while in a pure electric vehicle, the battery can be up to 400 volts and even more for larger vehicles. So this brings us to all kinds of new risks which I'm going to address today. Now, traditionally, in an internal combustion engine vehicle, the main risk is its fuel, be it petrol, diesel, or even LNG. So these are flammable materials which can cause a spark and can cause fire or even explosion. Now with EVs, battery EVs, we have the high voltages and there are new risks that must be taken into account when you work on them. Now, I would like to add a special note for hybrid vehicles. So these vehicles have both internal combustion engine as well as a high voltage battery. So it is a case of a double whammy because you have the risk from the fuel as well as the risk from the high voltage components of the electric vehicle. And you must be able to take note of these risks and take care of these risks before you work on them. Now, what are some of the risks in vehicles with high voltages? Broadly, I'm going to cover the four biggest and most common risks in vehicles with high voltages. They are electric shock, an explosion or fire, the release of explosive or toxic gases and liquids, and lastly, a unique feature in battery electric vehicles is low noise. Now, what is an electric shock? Electric shock can occur when you come into contact with any high voltage components. So this does not include only things inside the electric vehicle, even in your houses, your offices, your factories. We are using electrical equipment on a day-to-day basis. All of these will have its danger and can cause electric shock to the user. So the risk of electric shock in an electric vehicle is actually nothing new, because we as people in the modern society has been used to using equipment with high voltages, and yet most of us are safe as long as the equipment is in good working order. Now, what are some of the results of electric shock? Now, what is an electric shock? Electric shock occurs when there is a current flowing through the human body. And what can this cause? Firstly, it can cause a cardiac arrest. When current flows through the body, it actually disrupts the nervous system in our body. The nervous system is very important in sending signals from the brain to trigger the heart to beat. If this system is affected, a person may go into cardiac arrest, may lose consciousness, and eventually the heart will stop and potentially cause death. Another effect of electric shock, especially with much larger currents, is burns. When current passes through the body, it produces a large amount of heat, and this will actually cause burns to the human skin or muscles. And if severe enough, it can even cause fatality. The third one is not such a clear-cut effect of electric shock, but yet is something important enough for us to take notice of. When you get a small electric shock, you may lose balance and fall. Especially if you are working at a height and you fall, this can cause serious injuries, from broken legs to even broken heads, which may eventually cause fatalities. I will now show you a video that will briefly describe the cause and effects of electric shock.
In cartoons, it's pretty easy to tell when somebody's getting electrocuted. Their skeleton flashes through their skin, their hair sticks straight up, and there's smoke everywhere, maybe some electric sparks radiating out from their body. But what actually happens when you are shocked is much less flashy and much more dangerous. Technically, and thankfully, most of the cases we call electrocutions are actually electric shocks. An electric current running through a body. The word electrocution comes from a combination of the words electric and execution, so it was specifically combined to describe death by electric shock. Whether an electric shock becomes an electrocution depends on the nature of the current involved. A current is the flow of electric charge carried by electrons or ions, and our bodies are pretty responsive to them because they use currents all the time. For example, tiny electric pulses from the movement of ions across membranes are what trigger neurons and allow me to move and be alive and talk to you right now. So when you're shocked and a much stronger current passes through your body, the tissues it passes through can overreact to that gush. In cartoons, it's pretty easy to tell when somebody's getting electrocuted. Their skeleton flashes through their skin, their hair sticks.
So sorry for the technical disturbance. I will continue from where we stopped just now.
trigger neurons and allow me to move and be alive and talk to you right now. So when you're shocked and a much stronger current passes through your body, the tissues it passes through can overreact to that gush of electricity. In very mild cases, you might only feel a slight tingle in your skin, but as things ramp up, the current can cause mild to severe burns, muscle contractions, or even seizures because nerves and muscles are getting overstimulated. The amount of current that's flowing is measured in amperes, and a current of only 20 milliamps can cause someone to lose control of their diaphragm and stop breathing, and 100 milliamps can stop a heart. Now, more than 100 milliamps of current run through your phone charger, but touching its live wire won't kill you, not that I recommend you try it. It's not deadly because the amount of current in the wire isn't actually what matters. What matters is how much current gets into your body, and that's influenced by two things. The voltage, which is the difference in electrical potential that's driving the current, and your body's resistance to the current. Basically, if the current is like water flowing through a pipe, the voltage would be the water pressure, and the resistance would be like the narrowest section of the pipe, making it harder for the water to flow through. Your skin is pretty good at resisting current as long as the voltage isn't too high. It's a strong natural barrier to electric flow because it's dry and thick. It has way more resistance than the wires in your phone charger, so it experiences much less current. Of course, even when your skin resists the current, the energy from it still has to go somewhere, which is why heat is generated and why stronger shocks can burn you. Electricity above 500 volts is considered high voltage, and it's enough to punch through the resistant barrier of the skin and zap someone with enough current to stop their heart. In some cases, this is actually helpful. If the heart isn't beating right, the carefully targeted split-second 3,000-volt shock from a defibrillator can act like a reset button, allowing its muscles to fall back into a normal rhythm. But in a healthy person, stopping the heart is obviously very, very bad. When skin is damaged or wet, it has much less resistance. That's why hair dryers have those super strong warnings that using them in a bath can be fatal, even though a typical electric outlet is considered low voltage, about 120 volts in the US, 230 in Europe. So even though an electric shock can be mild and relatively harmless, even low voltage power sources can pose significant risks, and high voltage sources are always super dangerous, which is why you should always be aware of potential shock hazards, and hopefully you won't ever experience the true definition of electrocution. Thank you for watching this episode of SciShow. If you really are fascinated by electricity, you might want to check out the episode.
Alright, so I hope the video gives you a little more knowledge about what is an electric shock and what happens to you during an electric shock. I would like to next cover the second risk of a vehicle with high voltages, which is explosions or fires. Now, this is nothing new to vehicles. As mentioned earlier, in internal combustion engine vehicles, the fuel can cause fire. Now, in an electric vehicle, where does the source of energy comes from? So this source will be in the batteries. Now, when there is a sudden discharge of this energy, either caused by a short circuit or due to the breakdown of the battery membranes, it can potentially cause an explosion or fire. Now, one thing that is unique about batteries is that it can catch fire even while it is stationary. In other words, even though a car, an EV, may be parked in the car park, if you see smoke coming out of the vehicle, that is a telltale sign that eventually it may catch a fire. And it's best to try to stop it at this point of time. Now, this is caused by something known as the battery thermal runaway. When a battery membrane breaks down, it will cause an internal short circuit in the battery. This will cause a large current to flow within the battery, producing heat and eventually causing a breakdown and a fire. Now, this fire is quite difficult to put out because in a conventional way of putting out the fire, we are trying to cut off either the heat or the oxygen supply. In this case, burning of the battery cells will actually emit its own oxygen and produce its own heat, further making the putting out of battery fires a difficult task. And this is something that users should be aware of. I would like to show you a video. So this is a park bus. It's not moving, and you can see smoke starts to come out of the battery compartment of the bus before eventually turns into a large fire. Now, next, I would like to move on to the next series of battery electric vehicles. Specifically, this is again related to the batteries of the vehicle. Now, inside batteries, we have different kinds of chemicals and liquids. So these are very important to store the energy in it. And it's made up of different kinds of materials like lithium, cobalt, manganese, and others. Now, under normal conditions, all of these chemicals are contained within the body of the battery. However, if the batteries got damaged, for example, it is involved in a severe accident, or if there is inadvertent tampering of the batteries, then there is a possibility that you may cause these explosive or toxic gases and liquids to be released into the environment. Now, if someone comes into contact with these toxic gases or liquids, if it gets into the eye, it can irritate the eyes, or worse, cause eye damage to the point of losing your sight. Coming into contact with your skin can cause irritation or even chemical burns, and inhaling these chemicals into the human body may result in deep breathing difficulties. So, if you are not familiar with the batteries, and if you see that a battery is damaged, please do not try to repair it yourself and leave it to the professionals who will know what to do and how to handle these toxic and explosive gases and liquids. The last danger of a pure battery high voltage electric vehicle is its low noise. Now, you may be surprised to find that why low noise is a risk. Isn't human world already filled with noise? Too much noise, in fact, some people say, and we would all love to stay in a quieter environment. So, in an internal combustion engine vehicle, when it is running, when the engine is turned on, it will definitely generate noise. However, in a pure battery electric vehicle, the only thing that moves is the motor, and this is pretty silent because there are not many moving parts. In addition, for hybrid electric vehicles, when the engine is not in operation, it is also quite silent. This is especially true when the hybrid electric vehicle is moving at low speeds, for example, in the car park or along roads with elderly pedestrians or young kids. So what is the risk? Now, most people who live around cities or towns with vehicles have been conditioned to hear out for noises, and they will instinctively know that there is a vehicle in the vicinity. They will then increase their vigilance and try to avoid the danger. In the absence of noise, there is a risk that the surrounding pedestrians may not notice that there is a vehicle nearby and will not have the vigilance, and also may not be able to notice the unexpected movement of the vehicle. Let's say, for example, an EV is in the multi-story car park and is behind a person walking in the car park. The person may not be able to tell that a car is coming from behind. Fortunately, most car manufacturers have actually added in sounds when the motor is moving. So this is to overcome the problem of low noise. So next time when you are in an electric vehicle, if you hear a screeching sound when the car is moving, just take note that this is something that is intentionally built in to provide additional form of safety to people who are around the vehicle. So I would like to conclude with the saying that in overall, EVs are safe for use by the general public. Over the years, electric vehicle technology have improved tremendously, and safety has also been taken into account, and many more safety features have been added to electric vehicles over the years. Another thing that I would like to say is that over hundreds of years, humans have gotten used to internal combustion engine vehicles and think that they are safe. However, this is actually a human mind conditioning, and in fact, internal combustion engine do come with its own risks as well. And overall, an electric vehicle is no more dangerous than an internal combustion engine vehicle. So similar to an internal combustion engine vehicle, do not attempt to repair an electric vehicle yourself unless you have been specifically trained to do so. Otherwise, you may get into trouble with dangers such as electric shock or leakage of chemicals. In the next part of the presentation, I would like to share on what to do in an accident involving an electric vehicle. Now, an electric vehicle in its normal state is very safe. However, when there is an accident, due to the presence of the high voltage, there are additional dangers when you try to handle them. So, when an electric vehicle gets into an accident, these are some of the things to take note of. 1. Are there any indications of fire? 2. Are there any sparks, smoke, or vapor detected? 3. Can noises be heard inside the high voltage battery? So these can be indications that there is a problem with the high voltage battery due to sparking. And this can eventually cause an explosion. 4. Can you smell a pungent smell? If you do, there is a potential that there are leaks from the high voltage battery. 5. Are there any liquid leaking from the high voltage battery? If you see any liquid coming out of the high voltage battery, please do not try to touch them, as they can be corrosive and can even be explosive. 6. Is there any severe mechanical damage to any high voltage components in the vehicle? So if you see any orange components that are visible, do not touch them, as in an electric vehicle, any component that is color orange are typically high voltage components. And if they are damaged, then if you touch them, you may get electric shock. 7. Is there any visible damage to the high voltage cables? If you are able to see the metal conductor in the electric of a high voltage cable, please do not touch them, as they may still be potentially live. Touching them may result in having an electric shock. And lastly, is the temperature of the high voltage battery exceeding 80 degrees Celsius. If you notice that the temperature keeps increasing, there's a potential that the battery has already entered thermal runaway, and it's best to stay away from the vehicle at this point of time. Now, car manufacturers have also made safety precautions to ensure that even in an accident, the electric vehicle can still be safely, most users will still be safe. Now, one safety feature is that if the airbag has been deployed, it will automatically send a signal to cut off the high voltage system from the rest of the vehicle, and is totally disconnected from the high voltage batteries. However, even though the motors and the other high voltage components have been disconnected from the high voltages, the batteries will still have presence of high voltages. And one last thing to note is that do not proceed to touch the vehicle unless you can be sure that it is safe. Especially if you are unsure, do not do anything. Now, as every vehicle, every electric vehicle or internal combustion engine vehicle is designed differently the way to ensure its safety is also different. Therefore, manufacturers have came out with a document known as the Emergency Response Guide. So this is typically only a few pages long. Since different vehicle models and different manufacturers comes out with different high voltage structure, different function, equipment, and again different technology. So when you are coming to a vehicle that has had an accident, it is important before you approach it to familiarize yourself with the vehicle, especially its safety features as well as where its dangers are, before performing any work after an accident. Otherwise, you do not know where are the potential dangers and how to overcome all these dangers. So vehicle manufacturers, be it Tesla, Hyundai, or BYD, will provide a guide known as the Emergency Response Guide. This is typically available on the internet. You just type in Emergency Response Guide followed by the model of the vehicle. You should be able to find this Emergency Response Guide. Furthermore, some vehicles will also have a special QR code, typically near the dashboard of the vehicle, to open the Emergency Response Guide on the smartphone. So typically what is inside this guide? Two things: where are all the dangerous components, where the batteries are, where the high voltage components are, and where any other dangerous parts of the vehicle are. And secondly, how to cut off the high voltage before approaching the vehicle. They may tell you that there is a certain cable that needs to be cut or a certain plug that needs to be removed to ensure that the high voltage components of the vehicle have been safely disconnected. Now take note that this guide is meant to be used only in an emergency, and it's not meant to be a maintenance guide. For maintenance of vehicle, you will have to refer to a separate document which will be much more comprehensive than the emergency response guide over here. For the last part of today, I would like to introduce you to electric vehicle chargers. Now, as my colleague has mentioned earlier, in a traditional internal combustion engine vehicle, it gets its source of energy from the fuels like petrol and diesel. Combustion of the fuel will ignite the engine to provide kinetic energy to run the vehicle. On the other hand, an electric vehicle gets its energy from this battery. However, the battery does not provide you with infinite amount of energy. After a certain distance run, the energy in the battery will be depleted. Now, in a normal hybrid vehicle, this energy will be topped up from either regenerative braking or by running the engine to top up the state of charge of the battery. However, in a pure battery electric vehicle, this battery will have to be topped up from an external source, and this external source is an EV charger. The purpose of the EV charger is to pull electric current from the grid and deliver it to the EV. This is typically done through a plug or is sometimes known as a connector. So an electric vehicle stores all this energy in the form of chemical energy in a large battery pack, which eventually will be discharged to power the electric motor. So to recharge or charge out an EV, the EV charger connector is plugged into the electric car inlet via a charging cable. Now, one thing to note is that EV batteries, or in fact, all batteries can only accept direct current power. However, in almost all countries, the electricity grid is in the form of alternating current or AC. So, one way or another, this electrical energy needs to be converted from AC to DC to charge up the battery. And the equipment used to convert electrical energy from AC to DC is known as a charger. Now, you may have heard people talk about AC charging and DC charging. So what are the difference between these two? Now, before talking about the difference, let's talk about the similarities. The battery charging is still in DC, and electrical energy needs to be converted from AC to DC. Now, in AC charging, the current flowing in the electric vehicle charger cable is in the form of AC. So how is the electrical energy being connected to DC then? In this case, you have to depend on the charger that is located on the EV charger itself. Now, the advantage of this is that you are able to connect into almost any socket outlets, and AC is easily obtainable. But the disadvantage is that the charging speed, besides being limited by the AC charger, is also limited by the onboard charger in a vehicle. Take for example, you have a car with a 3.7 kilowatt onboard charger, and you use a 22 kilowatt AC charger. So, what is the maximum amount of power you can charge? The answer is only 3.7 kilowatts, because you are limited by the size of the onboard charger. So, you may ask the question, why not install a larger onboard charger? Now, this will have an impact in the form of size and weight, and will render the EV less efficient by increasing the size of the onboard charger. So another solution will be to adopt DC fast charging. In DC fast charging, the AC power is converted to DC power in the charging station as well, and on the cable and the connector to the EV, you will supply DC power. The advantage of this is by putting the converter in the charging station, you are less concerned with the size and weight. Thus, you are able to install a much larger charger, and this can allow you to charge at a much faster rate. Of course, the disadvantage is that today DC chargers are currently still more expensive. And secondly, DC chargers are also limited by the grid infrastructure of supplying that much of high power to the electric vehicle. So in Singapore, our national public charging standard is TR25 2022, and in TR25 2022 we have selected two standards. For AC, it will be the Type 2 charger. This can allow for both single-phase and three-phase AC charging. Whereas for DC charging, TR25 has adopted the DC Combo 2 chargers. An optional standard will be CHAdeMO, which you may also find in certain charging stations around Singapore. So, in Singapore, all electric vehicles sold minimally will be able to accept the AC Type 2 charger in its inlet, and optionally, but increasingly, most electric vehicles will also be able to accept the DC Combo 2 charger to allow for fast charging. Now, how do you know that an EV charger is safe to use? So the authority that is taking care of this part of the industry is the Land Transport Authority, or LTA in short. In order to install an EV charger in Singapore, you must first ensure that the EV charger has undergone a rigorous criteria, has met rigorous criteria that has been set out in TR25. Now, how do you know that this charger meets all the rigorous requirements? So, in order for an EV charger to be allowed to be sold in Singapore, it must first be type approved by the Land Transport Authority. Before LTA approves this model, it will require either the manufacturer or the importing agent to show that the EV charger model is able to meet this criteria by actually sending them to an approved laboratory for testing and obtaining a certificate. Once this certificate has been sent to LTA and LTA approves this charger, then it will be labeled as a TR25 approved EV chargers, and it will be issued with a sticker that you can see on the right. Now this sticker will be pasted on every EV charger that is sold in Singapore, and each model will have a unique sticker. So one model, one sticker. So 10 EV chargers of the same model will all have this same sticker. Now, take note of the sticker and see what it says in the middle. It says, please register the charger before use. Now, just by purchasing an approved EV charger doesn't mean you can use it immediately. For an EV charger to be allowed for use, it must also be registered with LTA. So EV chargers owners, so this can be for portable units, the owner of the portable units, and for units that are installed in the premises, the owner of the premises will have to ensure that the EV chargers purchased are registered with LTA. So, for this registration of these individual EV chargers, you must first ensure that it can be installed safely. So, owners are laymen. They do not know whether the EV charger has been installed safely. And thus, TR25 has a regimen of checklists to ensure that the EV charger has been installed safely. So first of all, the installation of the EV charger should be done by an authorized licensed electrical vehicle worker who will perform the installation, including the connection of the charger to the building or public electrical network, ensuring its safety. And there's another person who will have to certify the EV charger as well. This person is known as the EV charger specialist. So only after these two persons have checked the EV charger installed is safe by signing the checklist, then the owner can submit this checklist to LTA for registration, and upon successful registration, a registration mark like what you see on the right will be issued and must be affixed onto the charger. So as an EV user, if you drive to an EV charger and if you do not see this sticker, it means that this charger has not been approved and you should not use it. So installation of these EV chargers must be done only by a licensed electrical worker. EV chargers must be installed and certified by the relevant persons. And finally, the certification of EV chargers are done by the EV charger equipment specialists. Now, once you install and you use, how do you ensure that the EV charger is still safe after 1 year, after 2 years, or after an indeterminate period of time? To ensure the safety of users, TR25 has also come out with a mandatory periodic inspection and maintenance of EV chargers. So this is on the owners of EV chargers owners to ensure that their EV chargers undergo periodic inspection and maintenance. So under TR25, EV chargers are broken down into two categories. In the first category, which are restricted access, so these are typically for domestic houses. So in Singapore context, this will only include landed houses. Then you may ask, how about locations such as HDB car parks or condominium car parks? Aren't they also domestic premises? However, there's one key difference. In this case, the EV charger can be accessed by people who are not the owner, and thus it is categorized under the category of non-restricted access. Under the restricted access locations, the requirements for periodic inspection and maintenance is once every 24 months by a qualified EV charger equipment specialist. On the other hand, for non-restricted access, due to the higher usage levels and also accessibility by public users, the inspection and maintenance regime is more stringent. So in this case, every 6 months by an EV charger equipment specialist, and every 12 months by a licensed electrical worker of the appropriate grade. So I want to thank you all very much for coming to listen to the webinar tonight.